Hello boys and girls, this is Mrs. Juan Gervasio, and today we're going to be covering a brand new chapter, Chapter 2. Don't forget our heading for our notes. You need to have the lesson number and the title of today's lesson, which is on rational numbers. Also, please make sure you always date your notes and to highlight your title. Okay, let's go ahead and begin. We're going to go ahead and start off with the first thing is our key idea. So in this lesson, we're going to mainly talk about what a rational number is. So a rational number basically it's a number that can be written in this form a over b. And what does that mean? It basically means that a rational number is a fraction, where a and b are integers, any numbers that are positive or negative, but b just can't be zero. So you can never have zero down here. So I have here this chart I would like you to copy down, so please copy down this chart. It's saying that in this box, a rational number, anything in this box, so if you see there's two ovals in this box, anything you see here, that's a rational number. So an integer is a rational number. What an integer is as a reminder, it's either negative or positive numbers. So in this case, they have two negatives. Also, a whole number. A whole number is also a rational number. A whole number is any number you can count from all the way to a million or a trillion, but they are positive numbers. So I'm going to put positive here. And then integers are positive or negative whole numbers. So anything you see in the box will tell you that they are rational numbers. So as a quick recap, an integer is a rational number. A whole number is also a rational number. So these are some examples that the book gave you. If you can just please copy this down, and we're going to talk more about this in class tomorrow. Okay, so the main idea of this lesson and this slide is that you need to know a rational number is, or rational numbers are fractions. All rational numbers are fractions. You see a fraction, it's a rational number. Now, you might wonder about this number here, it's a decimal, and this number here, it's a decimal. Will it be a fraction? Can you turn it into a fraction? So we're going to talk about that in today's lesson in the video. Okay, so let's go ahead and move on to our next key term. You need to know what a terminating decimal is. So a terminating decimal is basically a decimal that ends. So take, for example, your GPA. Let's say you have a 3.12 GPA. That's a really good GPA, by the way. And if you notice, it doesn't continue. It stops at the 2. So this is what a terminating decimal looks like. It's a decimal that ends and it doesn't have any numbers that go on or repeat. And repeating decimals is when you have a decimal that has a pattern that repeats. So let's say you have your GPA is 3.12, but this time the 2 keeps on repeating. So if the 2 keeps on repeating, what I'm going to do is I'm going to put a bar, it's called a repeating bar, on top of the 2, and that tells me that the 2 keeps on repeating. Here's another example of a repeating decimal. You can have a 2.7575. Now, what keeps on repeating? You notice, is it just a 7 or is it a 7.5? If it's just a 7, we will put a bar on just the 7. But because it's a 7.5, we'll put a bar on all the way to the 5.75. So our answers for this one would be just 3.12 with a bar on top of the 2, or this one, 2.75 with a bar on top of the 7 and the 5. So that's a repeating decimal, and that's a terminating decimal. Please make sure you copy both of these examples or key terms down in your notes. All right, let's go ahead and do our first example. In our first example, we have here two fractions. And what it's asking us to do is we need to write the fraction as a decimal now. So to do that, what we need to do is divide. Now, in letter A example, I notice that this fraction right here is a mixed number. A mixed number, as a reminder, is a whole number with a fraction. Now, we can't change this into a decimal until we change it into improper. So to do that, we're going to multiply this by 2 times 4 plus 1. 2 times 4 is 8 plus 1 is 9. So we're going to say 9 over 4 with the negative. Don't forget that. Now we have what is called an improper. The top number is always on big, so that's called an improper. So what we do now is we're going to go ahead and divide. What do we divide? Top goes in. When we're dividing, the top always goes in, bottom goes out. So if you can just repeat that, top goes in, bottom goes out. So now we divide just like we normally would. 4 into 9, that's going to be 2 times, so we're going to put 2. 4 times 2 is 8. 9 minus 8 is 1. Since I don't have another number, I need to drop a decimal and add a 0. If I drop a 0 there, drop a 0 here. And then you have here 4 into 10 is going to be 2. But before I do that, I need to make sure I don't forget my decimal. Please don't do that. Forget 2. And 4 into 10 will be closest to 2 again. So that's going to be 8. And then 10 minus 8 is 2. Since I have no more values here, I need to drop a 0. Drop a 0 here. And then 4 into 20 is going to be 5. So my answer, almost done, is 2.25. But because it's a negative here, I'm going to put negative 2.25 as my final answer. Again, we're just dividing just to get our fraction into a decimal. So let's go ahead and divide this next one. 5 over 11. We have here 5. Top goes in and bottom goes out. It really helps when you say it to yourself. Top goes in, bottom goes out, and then you remember what to do. So 11, does it go into 5? Nope. So I'll drop a decimal, add a 0. 11 goes into 50. Close or exact? I would say close. And since there's a decimal, I'm going to put it here. 11 goes into 50, if I remember my tables correctly, 4 times. And 11 times 4 is 44. And then 50 times, or 50 subtract 44 is 6. Since I don't have any more numbers, I'm going to add another 0. 11 into 60 is closest to 5. And that's going to be 55. And then I have 5 left over. Bring down another 0. 11 into 50 again will be closest to 4. So 11 times 4 is 44. And then 50 minus 44 is 6. Drop another 0. And then I notice 11 times 60 is going to be 5 again. And 11 times 5 is 55. Do you notice there's a repeating pattern? What keeps on being repeated? I notice that the 4 and the 5 keeps on being repeated. So since the 4 and the 5 is being repeated, I'm going to go ahead and put a repeating bar on top of the 4 and the 5. So my final answer would be 0.45 with the repeating on top of both the 4 and the 5. That tells me the next number would be 4, 5, 4, 5, 4, 5. So that would be my answer for 5 over 11. So 5 over 11 is the same as 0.45 repeating. Okay, so this was converting fractions to decimals. So I would like for you to take these fractions here and change them into decimals. Don't forget, if you have a mixed number, you got to change it to an improper. So number 2 and number 4. So this is on your own. If you can do this on a separate sheet of paper and not in your notes, that would be great. So problems 1, 2, 3, and 4. Any questions you have, I will answer them tomorrow. All right, example 2. In example 2, instead of taking our fraction to decimals, we're going to take our decimal and change it into a fraction. But we have to put it in simplest form, which basically means we have to make it the smallest fraction we can make it. Now, you would need to know your place value. So I have here a chart, which I will talk about tomorrow in class also, that tells you the place value of our decimal. So if you look at 0.26, 0.26 lands right here, 0.26. You need to look always at the last number. The last number of your decimal always tells you what the fraction at the bottom denominator will be. So I look at the 6. The 6 is in the hundreds. It's in the hundreds place. So to make it a fraction, I'm going to put 100 at the bottom, and then just use exactly what the number has without the decimals. It has 26, so I'm going to put 26 here, and that would be my fraction. 26 over 100 is the same as 0.26. Now, since it's a negative here, don't forget to put my negative. Now, one more problem though. We need to make sure that it's in simplest form. Simplest form basically means, is it in the smallest fraction it can be? I'm looking at this. It looks like it's an even number, both top and bottom, numerator and denominator. So I actually can reduce this by 2. So since I can reduce this by 2, that's a 2, sorry. I'm going to divide 26 into 2, which is 13. And then I have 100 into 2, which is going to be 50. Can I reduce it anymore? If I can't, this would be my final answer. So my final answer would be negative 13 over 50. 26 over 100 would be negative 26 over 100 would be a good answer, but this is the best answer because it's simplified. Does that make sense? Okay. All right, let's go ahead and have you practice on the same paper on your own paper, number 5, 6, 7, and 8. Changing the decimals into a fraction, and if you need, look back to your place value chart. Okay? All right. Let's go ahead and do our next example, example number 3. In example number 3, the story problem, again, for story problems, you only need to write down the math problem. You don't have to copy down the story problem. So we're talking about a few sea creatures here, and it says here, we want to know which sea creatures are deeper than the whale. We know the whale is already negative 0.8 down the ocean. we want to figure out, is it anglerfish, squid, or shark? Which one's deeper than the whale? So what we need to do is look at all of these. They're all fractions. So to compare them to the whale is a decimal, we need to change the fractions into decimals. So to do that, we're going to do top goes in, bottom goes out. So top goes in, bottom goes out. So I'm going to do that for each one. Top goes in. Oh, but for this one, we have to change it into improper. So 2 times 5 is 10, plus 1 is 11 over 5. So that would be the same as negative 2 over 1/5. So top goes in, bottom goes out. And this one, top goes in, bottom goes out. And if you finish each of these, you'll get your answer. So top goes in, bottom goes out. I'm going to go ahead, for the sake of time, I'm going to go ahead and just reveal the answers to some of these. So if I divide 13 into 10, I'm going to get 13 into 10. I'm going to get negative 1.3 because this was a negative. And then for 5 over 11, I'm going to get negative 2.2. And all I'm doing to get these answers is top goes in, bottom goes out, just like we did in our other examples. For this one, 2 over 11 is going to be negative 0.18. Now I need to compare to see which of these three creatures are going to be deeper than the whale. And if I look at the squid, and if I look at the squid and the anglerfish, they both have a negative 1.3, and it's actually way deeper than the whale. So the anglerfish and the squid would be the deepest from the whale because they are lower than this number. 0.8 is actually higher than this, so negative 1.3 and negative 2.2 is going to be much smaller on the number line than this number. So these are the two answers, anglerfish and squid. Okay, using the same information, I would like for you to go ahead and answer number 9 on the same paper. It's also on your own. If the elevation of the dolphin is negative 1 over 10 kilometers, which of the sea creatures in example 3 are deeper than the dolphin? So you might want to refer back to this, go back and rewind this if you need to refer to this to figure out which of the sea creatures are deeper than the dolphin if the dolphin is negative 1 over 10. Okay? Don't forget to also explain. All right, exit ticket. If you can answer these two questions on your own paper for your exit ticket, that would be great. We will check these questions tomorrow, and if you have any questions on today's video, please feel free to ask me tomorrow. As a reminder, don't forget your notes, your on your own, and your exit ticket. Don't forget, these two are always on the same paper. Okay? And I will talk to you guys tomorrow. Bye-bye.